Have you ever had a perfect rock-solid plan just completely blow up in your face? Well, our technology, it faces that same kind of chaos, but every single second. Today we're going to dive into the secret sauce that keeps our whole world running when things go sideways: technological flexibility. I mean, we've all been there, right? You map out every single detail, you try to account for everything, and then, bam, reality hits. One little unexpected delay, one tiny disruption, and the entire thing just comes crashing down. It's a feeling we all know, and it's a problem our technology is battling constantly. And the answer to all that chaos? It's what we call technological flexibility. And listen, this is not just another buzzword. This is a core design philosophy. It's all about building systems that don't just follow a strict, rigid script, but can actually improvise. Systems that can bend without breaking. In a world that's basically defined by stress and uncertainty, flexibility, that's the ultimate survival trait.
Okay, so where does this idea of flexibility actually show up? Well, let's start in the digital world, in the realm of artificial intelligence. How does a machine, a piece of code, actually learn to adapt? One of the biggest testing grounds for this right now is our global supply chains.
Okay, so picture this. You're a company, you're importing some crucial parts, and your big shipment gets stuck in customs. Now, with traditional sourcing, which is almost always about finding the absolute lowest price, that's a potential catastrophe. Your whole production line could just grind to a halt. But AI-powered sourcing, that's a whole different ballgame. Yeah, it might cost a little more upfront, but it's not just optimizing for cost, it's optimizing for resilience. It actually builds in the flexibility to see disruptions coming and find a new route, which gives you a huge advantage when things inevitably go wrong.
And this really highlights the central trade-off here. Research from Niu, Zhang, and Wang points this out perfectly. While AI gives you this incredible adaptability, it's not always going to be the cheapest option on paper. Choosing to be flexible is a strategic move. It's a very deliberate investment in being resilient, and that resilience, well, it has a price tag. But the real challenge for AI here goes so much deeper than just dollars and cents. The ultimate test of flexibility isn't about navigating our man-made systems. It's about trying to model the most complex and adaptable system we know of, life itself. Take proteins, for instance. AI models like AlphaFold V2 they're just revolutionary. They can look at a protein's genetic code and predict its incredibly complex 3D shape with just mind-blowing accuracy. It's a massive scientific leap forward that's changing everything from drug discovery to how we understand disease.
But, and this is a huge but, here's the catch. A protein isn't some rigid, static little sculpture. Its actual function, whether it's an antibody tagging a virus or an enzyme doing its job, comes from its ability to move, to wiggle, to change its shape dynamically. And this is where AI is still struggling. It can predict the snapshot, but it often completely misses the movie.
And that gap between the snapshot and the movie, it's not small. It is massive. Research from Hake and his team found that for nearly 28% of protein types, the AI's static prediction completely misses the real-world flexibility that is absolutely essential for that protein's biological job. It's a huge reminder that true dynamic flexibility is one of nature's secrets that AI just hasn't fully cracked yet. Okay, so we've been in the digital world. Now let's see how this whole concept of flexibility translates from code into the physical world. We're moving from the abstract challenge of prediction to the tangible world of robotics, where adaptability is something you can literally see and touch.
So think about this engineering puzzle. Most wheeled robots are kind of limited, right? They can go forward, backward, maybe turn in a big, wide arc. But how do you build one that can just effortlessly slide sideways or spin perfectly in place and move with total freedom in a really tight, cramped space? How do you give it real physical adaptability?
Well, the solution from Liu and his colleagues is just pure mechanical elegance. Instead of relying on super complex software, the robot uses this clever linkage system to physically switch between two modes. In mode 1, it just glides smoothly in any direction, forward, backward, sideways, you name it. Then with a quick mechanical shift, it's in mode 2. The wheels pivot and it can rotate on a dime. It's flexibility that's literally baked right into the hardware.
Now let's zoom way in. Flexibility isn't just for big robots navigating a warehouse. It can also be engineered at the microscopic level, inside the computer chips that power our entire world, to stop them from breaking under pressure.
So inside all our electronics, you have these tiny components that expand and contract with heat, kind of like a steel bridge swelling on a super hot day. If those parts aren't designed to be flexible, they crack. As you can see, the traditional design methods, they just couldn't handle this kind of complex stress, and that led to failures. But a new, adaptive method developed by MAD lets engineers design flexible parts that can take the heat, making our electronics way more reliable.
So we've seen flexibility in digital predictions and in physical robots. Let's zoom out one last time and see how these principles all connect to build stronger, more resilient systems across the board.
This philosophy is popping up everywhere, weaving flexibility into the very fabric of our lives. In finance, work by Chen and others shows how adaptable IT systems can help companies absorb sudden economic shocks. And in our workplaces, research by Farashai and colleagues is using cloud AI to analyze how we interact with machines, creating safer, more responsive environments. See, it's the same core idea, just applied on a massive, societal scale.
So what does this all add up to? Well, technological flexibility isn't just one thing. It's an entire ecosystem. You've got the predictive power of AI, the physical adaptability of robots, and the smart integration of data, all working together to create systems that don't just survive shocks, but can actually thrive under pressure.
So, look, if you take one thing away from all of this, let it be this. Flexibility is so much more than just a feature. It's a fundamental design philosophy. It's a whole way of thinking that applies from the code in our software and the gears in our robots, all the way up to our global economic and social systems.
Which leaves us with one final, really important question. In a future that we know is only going to get more complex, more unpredictable, is it possible that our technology's ability to adapt, its innate flexibility, will turn out to be the most important thing we ever build?